All right. We're going to continue on, and we're going to talk about example number 1 on 3.2c. And if you recall, we are talking about these 9th grade students going backpacking on a backpacking trip again. This was on 3.2b, example number 1, so we're going to continue on this little journey that they're having. We found our least squares regression line by going through, and I still have this in here, so if you go to second calculate, or you go to edit, and then you look at your list 1 and list 2. That's where I put my data in. And if you go to stat and you go to calculate and go down to 8, what you get is our different values. So you put list 1, list 2 in there, and you can calculate this. Now from here, we can see that we have our y-intercept and our slope, but we also find our squared value, and this is one of the things that we want to find. All right, so our r squared value is 0.632, and you can see that our r value is also going to be 0.795. Now, if you're wondering how can we get that r value from r squared, well, you'll recall, okay, that if we take the square root of r squared, so if you take the square root of 0.632, all right, obviously there'll be a little bit of rounding, and you can see that this is what we have for our r value. Now, the question is, what is r squared? And we can talk about the difference between r squared and r, but really want to find r squared, and now we want to interpret it. So how do we interpret r squared? Well, r squared, what this means is about, all right, 63.2%. That's what an r squared value is. It's really a percentage, all right, about 63.2% of the variation or variability. In our output, so in the backpack weight is accounted for by the least squares regression line, and that's what we know. So about 63.2% of the variability in the backpack weight is accounted for by the least square regression line, which is located right here. Okay, and so how is that different than if we were to talk about our r value? Well, the r value just tells us something about the least squares regression line. It tells us about its strength and its direction. And so what we could say is from this value, we could say that the relationship between body weight and backpack weight is moderately strong. So it's pretty strong. Moderately strong, positive linear relationship. And that's what it tells us there, okay? Tells us about the linear relationship and whether it's going to be how strong it is. So 0.79 is moderately strong, fairly strong, and it is positive because it is positive right there, and we saw it before. Now, next thing we want to talk about is our S value. The S value is the standard deviation of the residuals, all right? And how do we find the standard deviation of the residuals? Well, we take the square root of the sum of the residuals squared, okay, divided by n minus 2. And so how do you do this on your calculator? Well, right here, we're going to take the square root. Okay, we're going to take the square root, and I'm going to take the sum. So we're going to go to second stat, and we're going to math. And if you go to that, you press 5. We're going to take the sum of our residuals. So go to second stat, all right, and we're going to 8, our residuals. And we're going to take that value and square it. Okay, and close that, and we're going to divide by the n value. Our n value here is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total values, minus how many variables we have? Well, we have 1 and 2 variables. Boom, right there. And I believe that's all. And when we press enter, bada bing, bada boom, we found our S value to equal 2.27. And so what does this 2.27 mean? Well, we know that the actual, all right, backpack weight typically varies by how much? 2.27 pounds from the predicted weight from the, where do we get that? Least squares regression line, and that's what we know. The actual backpack weight typically varies by 2.27 pounds from the predicted weight from the least squares regression line. And that's what we got. That is the standard deviation of the residuals. That's our S value. So how much does that typically vary from the predicted weight of the least squares regression line? R squared tells about the percent of variation, variability from the backpack weight from the least squares regression line, accounted for by that. And we also talked about how to find this least squares regression line and a lot of other cool stuff. All right, well, here's an example of going through there. Hope this helps you out, and also how to use a calculator. So yeah, good luck and God bless in the rest of your problems.